Alright, so now we're going to be starting the coding part for minimum time to reach problem. Minimum time to reach the last room. So basically, I explained to you in the last video, and now basically move time is basically the 2D array that has been provided to us, and so we write move time. Int n is equal to move time dot size, and int m would be equal to move time dot move time of 0 dot size. So basically, uh, in this case, n is the number of rows and n is the number of m is the number of columns. And now what we need to do is we basically need to make a priority queue, since we're following the Dijkstra's algorithm here. As explained to you in the video, I basically told you that first we follow the Dijkstra's algorithm to basically get the shortest path. This is similar to the shortest path algorithm because we honestly need to we basically need to find the minimum time to reach the last room, right? So the priority queue we take, basically taking this to store the time, row, and the column, and then we'll extract the minimum from these. So priority queue of vector of int type, comma vector of int, and we set greater because we'll be taking the minimum first, right? So greater, and we make it, name it as pq, and so basically storing the time, the row, and the column in this priority queue, right? And now we push the value of move time, but initially we also need to make sure that move time of 0 0 is set to 0, right? This I've done because we can have any value here initialized in this 0 comma 0 grid column cell value. We can have any value, and we must not confuse that with another time, right? So in case the value of this part here is higher, in case this was 6, the value of the output would still be 3 because this starting cell element does not matter, right? So we can set this as 0, and then we push the same. Once we have set this to 0, we can push this into the priority queue, and the x and y coordinates of the first cell, the top left cell, is 0 comma 0 only. So once we've done this, we start the Dijkstra's, right? So basically, priority queue is not empty, while the priority queue is not empty, we're going to firstly take the topmost element of the priority queue and then pop it. The standard algorithm that we use. Then we take auto current is equal to auto current would be pq dot top, right? And now int time is equal to current of 0, and similarly x and y coordinates we get 1. This is the x coordinate and this is the y coordinate. Now what we're going to do is we're going to check if we have already reached the bottom right cell. That is our destination, right? That is the target value. So we check if we have already reached this cell. So that how we do, we check if x equal to n minus 1 and y is equal to m minus 1. Then we can continue. That means we have already, no, not continue, we can return the time because we have already reached here. And now moving on to, we basically now want to traverse the traverse each cell, right? Since we have to visit the neighbors, so we'll go in all 4 directions. So we'll say for auto and d in directions, I need to make this array, this vector. So this will be a 2D array which will store the directions. So let me just make it, declare it here. So vector of vector, or let me just make it here globally. So vector of in type directions is equal to, so this one is going towards the right because in horizontal we move 1 unit towards the right, but in vertical we don't move. So 1 0, then minus 1 0, this is left because this is going towards the negative x axis. Then 0 comma 1, this is going towards the positive y axis, and the down one is 0 comma minus 1 because this is going to negative y axis. So directions we have stored, so we have to visit all 4 directions, right? And we also need to make sure when we're visiting that it is inbound. So let me first write down the value nr x plus nr is next row, x plus d of 0, which will take the x value, and nc y plus d of 1, right? And we need to make sure that this is valid, right? So we have to make sure that if is valid function we create, if is valid, in which we pass the row and column or the cell that we are going to, and the n and m, the number of rows and number of columns. If it is valid, then we can go and visit, and this makes sure that we are within the bounds, so in bounds. So I'll make this function right, in bounds. So this function I'll just declare, but before that what we need to do here is we need to say the next time. Int next time is equal to max of the move time nrnc, and the time that we basically check, the time that is increasing, that we are increasing, right, time uh, plus 1, right, because the time keeps on increasing and we need to make sure that the next time is getting stored correctly. And then we can finally, once we have done this, we can return our value, but return time is already here, so here we have to return -1, because if it comes out of the loop, that means that we are unable to find the minimum time, uh, right. So I think this is the way. Also, we forgot to push the next elements. So we basically have to pq dot push the next time, not just the next time, but the next row and the next column as well, since we are pushing it into the priority queue. And once, if we run it, let's see. Yeah, we haven't made the is valid function yet, so let me make this function for you. So the function is of bool type, either true or false. Bool is valid. It'll take int I, int j, int n, and int m. So if I greater than equal to 0, and I less than n, and j greater than equal to 0, and j less than m, so this means that it is in bounds, perfectly in bounds. So then we return true, else we return false, right. So this means that it is in bounds, is valid function checks for that. And now we can see, okay, so we're getting time limit exceeded and only 9 on 744 test cases passed. So we know if we are exceeding the time limit, then what we need to do, we'll have to use dynamic programming. So let us declare dp vector vector dp, right, and in this we can store here, first let me write vector of int, no sorry, n comma vector of int max, right. So we're going to be storing the max value here. And basically dp of ij would tell us about, it would denote the minimum time required to reach cell I comma j, right. So dp ij is equal to minimum time required to reach cell, and I forgot to write m here, so it is n cross m matrix, so that is why we also have a dp of n cross m, right. Now now we check here, after declaring these, if in case our time greater than or equal to dp of xy, that means uh, we have to continue. Basically what we're doing here is that if in case our time, or if we have already found a shorter path, by shorter path I mean lesser time, if we found a lesser time to cover that, then we can skip this one, so we'll use that. And we also need to make an addition here, that if in case next time next time is less than dp of nr comma nc, that means that only in the case that if the next time is less than the one that is stored, if the next time is less than the one stored, then only we'll push the next time in it. And now let's try to run it, right, continue, okay. Now again our time limit is being exceeded, so I think we haven't declared something correctly, so let me see. Okay, so I reviewed the code and I saw that we haven't declared this dp of xy equal to time. So that is the most important step in whenever you're solving a dp problem. You have to store the value of whatever variable into the dp matrix. So yes, as you can see, it has been accepted. And yeah, so this was the problem that integrated dp as well as the bfs algorithm, the Dijkstra algorithm I mean, or the shortest path algorithm. And yeah, that's it about the video.